Sorry, say that again?
Can you hear the wind noise?
Yeah.
You can't hear now, can you?
No. Wait, say something?
Hello?
Okay, yeah, you're good. Oh. Wait, what's the password to Love STEM Club's Twitch?
Uh,
Uh,
you don't have
uh,
a save?
no, I do not.
Oh, I have a save.
I mean, I can just do forget password. I think I have.
What?
I just need the Twitch account. I can just forget
I
pass.
sent I sent it in your Discord.
Okay. Oh man, it's epic password.
Good
Okay.
password.
Oh bloody yay. Okay, hang on. Oh wait, I don't have to. Okay. Wait. You need to go look on Love STEM Club's email. Wait, so I manage the YouTube channel, but I don't get the. But it doesn't like YouTube, like Google doesn't just automatically also like have
Five
the
two seven eight eight eight.
527888.
Also, wait, my headphones battery says it's running low.
Dude,
That's
how?
not good.
Why is it always like?
I
Why is?
just I I don't know. I only have one USB-C charger, and I
I
usually
mean,
use it to charge my computer overnight.
same.
So then I don't charge my headphones.
So
And
what
then,
I do is I charge my headphones when I'm like eating, eating. That's like it.
yeah, no, yeah, I should charge it more when I'm actually like, not using it.
Yeah.
But like, no, its battery is like totally fine though. Like, it can go up to like 16 hours, and it like charges super fast as well. Like, I
Only
just
16
don't charge.
SMH. Just
I
kidding.
just don't charge it a lot.
Okay. Yeah. Mine's like really awkward because mine's like just short enough that I can't use it for 2 days. Like just not enough battery for me to use it for 2 days. So it's like,
Wait, can you say something?
hello.
Uh,
How do I pin a comment on Twitch?
I'm gonna not use my headphones for now
Why not?
because it's gonna run out of battery.
Okay.
Is it? Can you hear your voice? Is it bad?
Yeah, no, I can't.
You can't?
I cannot.
Oh, okay, then it's kind of fine actually.
How do I do stuff on Twitch? How do I pin a comment on Twitch? I guess I'll just do this. What? Hang on.
So like,
Yeah?
if we have like Google Meets and like Twitch and like YouTube
Uh-huh.
streaming, how are we supposed to like check all the chats at like the same time?
I got you.
What?
So Restreamio can do like two chats at once. So hang on. I guess I can do this. So I can pop this out. Oh, come on. Okay. What? OBS, you're garbage. Holy crap.
Wait, it says there's 3 people watching this on
On what?
Twitch.
Well, who would they be? Would you happen to know?
Can't you look at it on?
I could look at it. Give me a second here, Austin. Alright, let's see. Who is here? Well, there's you.
Yes.
There's me.
Yes.
That's it.
Wait, what? Oh, there were 3 people. The other person was scared away.
Yep.
Okay.
Oh, it does say 3 viewers. Oh, it does say 3 viewers. Oh my, I just heard my own voice.
I think that's on your end.
Yeah. I opened it on my phone and I forgot I have like max volume. Okay, so Twitch is working with audio. YouTube should also be working. Oh crap! I replied on Restreamio. Oh no. So it sent hi in both chats.
What?
Don't worry about it. Okay. So YouTube also works.
Wait, it says
Okay.
hi in both chats?
Yeah, in both Twitch and YouTube.
How does that work?
The same way as streams to both Twitch and YouTube, probably. I just realized I probably didn't even need Restreamio. I could have just ran 2 instances of OBS.
What? It probably didn't even.
Oh, I just heard myself.
I think it was on my end, but I mean.
Okay. Alright.
Okay.
Are we gonna start 43 minutes later?
Yeah. So do you. So how do you want to do this?
Well, okay. I guess we can. Oh, okay. Alright, since we streamed for like so long before we actually start, I'm gonna record this and I'm just gonna like delete the stream and upload the recording, okay? So, okay, so do you want to start?
Okay. Do you want me to read all the problems?
I couldn't care less. If you do you want me to read all the problems?
I don't care.
Well, we're gonna have to come up with a compromise, or
Uh,
else we're never gonna leave.
uh, uh, I'll read all the odd slides, and you read all the even. Wait, that's not
Okay,
gonna work, because we're
why
gonna
not?
make new slides.
I'm gonna what?
We're gonna make new slides probably, if we
Oh,
run out
okay,
of space.
okay.
So, um, Yeah, I'll just read all of them. Okay.
Oh, okay, I guess.
Okay. Are we starting?
Yeah, hang on. I guess I can start. Okay. Yep, I'm starting it.
Okay, Mayday has an infinite number of balls and empty boxes available to her. The empty boxes, each capable of holding four balls, are arranged in a row from left to right. At the first step, she places a ball in the first box of the row. At each subsequent step, she places a ball in the first box of the row that still has room for a ball and empties any previous boxes. How many balls in total are in the boxes as a result of Matey's 2010th step?
Okay. So, how do you
So,
think we should start off with this?
so you first, I would say you first want to get a general idea of like what's actually happening, right?
Okay.
So, So you have like empty boxes, and for
Yep.
simplicity, I'm just gonna put them as like underlines.
Okay, you do that.
Uh,
You can do it.
boom, 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 boom. Okay, hold on. Boom, boom. Okay, so like this is box one,
Yep.
box two, etc. Okay, so at the first step, she places a ball in the first box of the row. I'm just gonna put that as a tally mark. And then at each subsequent step, she places a ball in the first box of the row that still has room for a ball and empties any previous boxes. So let's think about like what's how that's working. So she's gonna place a ball in the first box of the row that still has room for a ball. That's gonna be box one. And
Hmm.
she's gonna empty any previous boxes, but there aren't any previous boxes because we're on box one, right? So she's gonna keep on filling this up. So we're gonna have four balls, and then each box is capable of holding footballs, right?
Yes.
So whenever she places a ball in this situation, she has to place a ball in box two, right? But then
Hmm.
it says she's going to empty any previous boxes. So then all the stuff in box one is going to go away. And now we just have a thing in box two. And then what she's going to do now is she's going to start filling up box one again, right? Because she's going to place a ball in the first box of the row, right? So she's going to keep
Yep.
on filling this up. Then after this is filled up, she can't put any more in it. So she's going to have to put a ball in box two. But then if she places a ball in box two, she's going to have to empty all subsequent boxes, right?
Yes.
And then it's going to go in a pattern like this, right? So I'm going to fill up box one and then add one to box two and then erase all box one and then fill up box one and then add one to box two and then it all goes away. And then I'm going to fill up box one, and then when it's in this situation,
Now you get to
box
do
two is
box.
full,
Hmm.
and then I had to start filling box three, but then I'm going to empty all of box one and box two.
Yes.
And I just have one thing in box two.
So now you basically do the same thing again, but then until like you do a second mark on box three.
Okay, so one way um you can start thinking about this is thinking like how many balls am I gonna need to like put one ball in a certain box, right?
Yeah.
So um so I can start thinking about box two, right? How many balls do I need to put in to put one ball in box two? Well, I I had to put four balls in box one, and then I could put a ball in box two, right? And then all my balls in box one goes away, but I put in five balls, right? And then my
Hmm.
net gain was one ball in box two, right? So we can say that if I put in five balls, then it's going to be one ball in box two, right?
Yes.
And then so every ball I put in box two, I can think about it as I'm putting in five balls, right?
And then
So if
like
I have four balls in box two, that I put in 20 balls, right? And then we can think about how many balls am I going to need? to put one ball in box 3. Well, to put one ball in box 3, I'm going to need all of box 1 and box 2 filled, right? How many balls is that going to take? Well,
That'll take
the balls in
5
box
balls.
1, those are just one ball, right? And then the balls in box 2, those are going to be 5 balls each, so those are 20 balls. And then I'm going to put one ball in box 3, and then all the other balls are going to go away, right? So that's one more ball, and then that adds up to 25, right? So what happened there was I put in 25 balls, and I'm left with a net gain of one ball in box 3. So then I can say 25 balls is going to be one ball in box 3. And then you can keep continuing this pattern, and you can see that um, each subsequent box is just going to take the next power 5 balls. So then it's going to be, I'm going to need 125 balls to put one ball in box 4, and then 625 balls to put one ball in box 5.
Or just
Uh,
like powers to 5 in this case.
yeah, and then if I go to the next power 5, that's going to be too big, right? So like what we're looking for here is we're going to put in 10 balls in total, and then we want to know like how many balls are actually in the boxes, right? So I can just label them all here. And so basically, we're just going to look at um, we're just going to look at like how many 625s are in 2010 and how many 125s are in 2010. Like basically, what we have here is just like we're just counting in base 5, right? So we're going to see how many 625s can be in 2010. So we can try like multiplying it by 3. So then we have 1875. And if we have another 625, it's going to be too big, right? So that means we can have 3 balls in box 5. And then we're going to be left with 2010 minus 1875 balls, um, which is going to be 135 balls. And then we can put one ball in box 4. That's going to be 125. And then we're going to have 10 balls left. We can't put any balls in box 3, but then we can put 2 balls in box 2. And then that gives us an answer of 6 balls in total. And you look at the answers. Yeah, the answer is 6 balls. So here the answer is 6 balls. And yeah, basically we're just counting in base 5. We're just converting.
Yeah.
We're just converting 2010 into base 5, and then we're summing its digits essentially.
So if you think about it, this actually kind of works like counting because like, so if you had like say if you were turning it like say in base 10 when you're counting in base 10 you count 1 and then 2 3 4 5 6 7 8 9 and then you go to 10 when you go to 10 you go to the next digit so you put 1 in the next digit and you get rid of everything else that goes back to 0 so it's kind of like counting and like it's kind of like just how bases work right just like how counting works
Yeah,
so in 10 in base 10 there's like 9 there will be nine balls you can put in each box because you can count up to 9 per digit. So if you can put 4 balls in a box, that's like you can count up to 4 each digit. So it's base 5. So you can just like so yeah, in essence you're turning 2010 into base 5
yeah,
and adding up the digits.
yeah.
Okay.
Okay. Let's
Next
move on now.
one.
Number 29. A sphere is inscribed in a right cone with base radius 12 centimeters and height 24 centimeters as shown. The radius of the sphere can be expressed as a times square root of c minus a centimeters. What is the value of a plus c? So we have a right cone, a sphere is inscribed in the right cone, and we want to find what the radius of the sphere is. So you can do this in a number of ways, but essentially you want to like set up a system so that you can like make equations and solve them.
Yeah.
So do you think should we show how you did it with similar triangles or my like right triangle thing?
We can do. So which one do you think would be better? Which one do you think what's the better solution?
I mean, both work,
Okay.
but I mean yours might be like more elegant. There's a
Okay.
little bit of stuff in mine.
Okay. So the way I solved this was that I took a cutaway of the cone. So basically, like if I were to cut this cone horizontally in half, and I took half of it like down the middle like this. So now we have this like right triangle here, right? We have this right triangle here that kind of looks like this. So this is the side of the cone. This is the side of the cone. And so this will be 12. This is 24. So get rid of this. So now let's think about the way the circle's in here. The circle's in here like the circle is like butting up against the cone on the top. So it's like it kind of looks like this. So it's like oh boy, it touches it there and goes there. And so here's the center. Say the center's right here. So this is R. We can call this R, and then we can extend here to the point where it's tangent to this because it's inscribed, so it's like tangent this side, and uh, the angle between a circle from the radius to the point of tangency and the tangent line is always a right angle. That's just the property of that. So that's a right angle. So now from this we can see that this is a right angle, and this is a right angle because we went from like the tip to the base, and this is a right cone, so that's a right angle. So now what we have here is actually, if we look, this, so both of these triangles, the outer triangle, like this big triangle and the smaller triangle, they both have a right angle and they share an angle. So both of these are similar. These are similar triangles. The big one, like the big one here, and this small one here. These two are similar triangles. So now
Yeah, or so like they have a right angle, but they also share the angle at their tip, like right
they
here,
share
right?
this angle.
Yeah.
So if we know they're similar, then they're like they're they have these same ratios. So the ratio of this side to this side is 1 to 2, right? So if we because we know that this is R, then this must be 2R. Okay, this must be 2R. And we can also find the so if this is 2R and this is R, this is a right triangle, then we can use Pythagorean theorem to find that this side, the side of this, 1, 2, so this will be square root of 5R. So this area right here, this will be square root of 5R. So this is square root of 5R, this is R. So square root of 5R plus R would end up equaling 24 because the total length of this is 24. So now to find R, we would just have to divide 24 by square root of 5 plus 1, which is 24 square root of 5 minus 1
You put
over.
24.
Oh, my bad. 24 square root of 5 minus 1, and then the bottom will be 5 minus 1, so 4. This will just turn to 6. So we end up with 6 square root of 5 minus 6. So that will be our radius. And the radius of the sphere can be expressed as a square root of c minus a. So we're looking for a plus c, which is be 6 plus 5 equals 11. So our answer will be 11.
Yeah, that's the right answer.
Yep.
Okay,
So,
should I show what I did?
yeah, so you're also you can show you.
Okay. I'm gonna put it on a new slide.
Okay.
Okay, so I also started out with like the same triangle as Bill. Uh, okay, so this side is 12, this side is 24, and then we have a circle here. Um, a circle here. So so it's going to be tangent at this point. It's going to be a right angle here, and then this is going to be the center of the circle. If I draw the center of the circle to the tangent point right here, this is going to be another right angle. So what I did was I first found the length of this large hypotenuse side. So if we have 12, 24, that's just a scaled up 1, 2, root 5 triangle, right? So then this side is going to be 12 root 5. And then so this point to these 2 points on the circle, they're both like tangents, right? So the length of the tangents are going to be the same. So then this length of the tangent is going to be 12, right? So that means that this length right here, it's going to be 12 root 5 minus 12. And then I can call the radius of this circle r. And then r is going to be right here as well. So then I can call this hypotenuse right here 24 minus r. So then if we're looking at this smaller right triangle right here, we can set up Pythagorean theorem, right? So 12 root 5 minus 12 squared plus r squared equals 24 minus r squared. And then you can just like multiply this out, and it's going to be a linear equation. So I guess I can multiply it out. So it's going to be like 144 times 5 plus 144, and then it's going to be minus 288 root 5 plus r squared, and then it's going to be equal to 24 squared minus 2 times 24r plus r squared. And then the r squares cancel. What you can do here is you can divide everything by 24. So I'm going to take out a 24 here. I'm going to take out a 24 here. That's going to be 24. So 144 is 12 times 12. So if I take out a 24, it's going to be just 6. And then this is going to be just 6. This is going to be 12. And then I can also take out another 2. So taking out a 2. And then, okay, and then putting that all together, I'm going to have 15 plus 3 minus 6 root 5. And it's equal to 12 minus r. So then r is going to be equal to 12 minus 18 plus 6 root 5. So then r is going to be equal to 6 root 5 minus 6. So then, yeah, a root c minus a, so then a is 6 and c is 5. So then a plus c is 1. So the same answer as well. So yeah, mine was a little bit more algebra. Yeah. I mean,
Yeah, Austin's was a bit more like algebra, tended more towards algebra. Mine was a bit more geometry, I think.
yeah. Um, yeah. Why did they say like a squared c minus a, and not like a and b?
I'm not sure actually, but that's up to the question writers. You can ask them.
Okay. I think either method here works fine. I usually just go with like the first thing that I can think of,
Yeah, don't
so
like
that I'm not
yeah,
thinking too long.
don't
Uh,
don't ever spend time thinking of like if thinking of like extra, thinking of methods that could be potentially more efficient. Just always go with like whatever comes to your mind first.
yeah.
Because or else you're more than likely to waste more time thinking about how you're gonna do the problem than like actually doing the problem.
I mean, I like you say that, but like like take it with kind of a grain of salt. Like
Yeah,
I don't
kind
know.
of grain of salt.
Like if you think of something, but like later you find out that it's not gonna work, you need to like ditch it. You don't want to spend too long on just using that either.
Yeah.
But like if you think of something and you see that like it's going to work, then like you should just go through with it.
Yeah, if you already like worked out like a logic on doing it, then like yeah, just go through with it.
Yeah. Okay, we can move on to the next question, number 30. If x and y are positive real numbers for which x plus y squared plus x minus y squared equals 10 and x plus y to the fourth plus x minus y to the fourth equals 98, what is the value of x, y? Express your answer in simplest radical form.
Okay. So to do this problem, we're gonna use something we use a bit, I think. Well, like we've seen it a bit. So to do this problem, we would set. You see that we actually have like something that like is repeated, like a phrase, like an expression that's repeated a lot, and which in this case is x plus y squared and x minus y squared. So to make this simpler, to simplify this for us, we can express these as set these as a. So we can have a as x plus y squared and b as x minus y squared. So now we can rewrite these equations as a plus b equals 10 and a squared plus b squared equals 98. So now this looks like something we're very familiar with, which is this, like x plus y equals something and x squared plus y squared equals something. So this is something like you see a whole lot. So now what we do to solve in this case is we square the top and we get a squared plus 2ab.
Yeah, so here, like if you have like a plus b and a squared plus b squared, you can solve for like ab, right?
Yeah.
Like essentially, like if you have like two of the three, then you can solve for the other one. And like A, B can be like pretty useful here, right? Because like
Yes.
we set A and B to be um like if you multiply x plus y and x minus y together, then you have like difference of squares, right? So it can be pretty helpful. Yeah, so we
Yes.
can solve for AB here.
Okay, so AB here will be AB will be equal to 1. So now we know that x plus y squared times x minus y squared equals 1. And this is also very familiar. This is just difference of squares. So we end up with x squared minus y squared, this in itself squared, equals 1, which just gives us x squared minus y squared equals 1. So now we have this. And let's see. So now we can think of like expanding this equation. So now we're looking at x squared and y squared. We can think of expanding the first equation, which isn't that hard to do, right? It's just square. So you end up with x squared plus 2xy plus y squared plus x squared minus 2xy minus y plus y squared, my bad, equals 10. So notice, I did this because I kind of noticed that if you expand these, the xy's are going to cancel out like this. So we'll be left with 2x squared plus 2y squared equals 10, and x squared plus y squared equals 5. So now we have x squared minus y squared equals 1, and x squared plus y squared equals 5. So this is like, this is pretty obvious to solve, I don't think. Y squared would be 2. If we know y squared equals 2, and then x squared will be equal to 3. So now to solve for xy, we can multiply x squared and y squared and square root them. So it would just be square root of 2 times 3, square root of 6. And that will be our answer, square root of 6.
Um, yeah. Uh, and the correct answer is yeah, square root of six. I also solved this in like the exact same way, pretty
Yeah,
much.
this is kind of like the bog standard way to solve it.
Also, but I think so. Like when you go from here to here, um, when you square root both sides, I think you have to be careful with that, right? Like you have to say x squared minus y squared can be equal to plus or minus one.
Oh, yeah.
But if you I if you solve like either case, like it gives you the same answer, root six.
Okay.
So that's, but I do think you should be like kind of careful with it.
Okay, that's my bad. Sorry. Okay.
Okay. Okay, let's move on. So now this is going to be 2010 Nationals target. We're starting on number one. Superman begins flying at a constant rate of 100 miles per hour. After 1 mile, he increases his flying rate by 20% and maintains the new rate for the duration of the second mile. He continues this pattern, increasing his rate by 20% at the beginning of each mile. During which mile does his rate first become at least 200 miles per hour? So this one isn't even about like speeds or anything. It's just like you're just increasing something by 20% and you're saying when it first becomes 200. And um so like all you're doing is like so like at the 0th mile, if this is zero and then like you're at one and then you're like at two. So you're starting at 100 and then you go to 1.2 times 100 and then it's going to be 1.2 squared times 100. And then all you need to do is find how many 1.2s you need to multiply 100 by to get above 200. And that's very easy since you also have a calculator in Target. So uh
Yep.
wait,
With
actually,
logarithms.
so because 200 is so close to 100, like this is gonna go to 200 pretty fast. So you could just keep multiplying 1.2 by 100, and then you can see that it takes four 1.2s to get to 100, or sorry, to get to 200. So then you can see that this is gonna happen on the fourth mile, right? Um, yeah. Wait. Wait, oh, so sorry, you should count it like, sorry, this is actually wrong. Like you should start counting the first mile as the first mile. So like
Okay.
this is the first mile, this is the second mile, and so on. So like you can see like at the end of the second mile, the 1.2 is going to be squared, and at the end of the first mile, the 1.2 is going to be raised to the first power. So if I'm going to get to 1.2 to the fourth times 100, then this is going to be at the end of the fourth mile. So then that means at the beginning of the fifth mile, it's going to reach 200. So then during which mile does his rate first become at least 200 miles per hour? That's going to be mile five. Yeah, that's the answer. Anything you wanted to say there, Bill?
Uh, yeah, so like on problems like this, it's sometimes better, it's sometimes not better, it's sometimes good to like hand write the first few. So like in this case, like do the first like do like the first mile one, mile two, and like see what happens after them to get an idea of like how the sequence goes, how the pattern goes. So you won't like make the mistake Austin did.
Yeah. Yeah. Also, so like the numbers in this problem were like I don't know, like pretty small. So you could just like multiply it out by hand and see that it's the fourth mile. But if it's like really big or like a really small percentage change, like like what you can do instead is just like set up an equation, right? So like just say like 1.2 to the x times 100 is equal to 200. You can solve this on your calculator, and then you have like x, it can be like some decimal number, right? But then you just round it up to the next whole number, and that, and yeah, and then at the end of that mile, it will become 200. Okay.
Mhm.
We can move on to the next question. For the list of five integers below, the mean and the median are equal. What is the sum of the three possible values of x? So we have five integers, and note that they are integers, so x can also be negative. The mean and median are equal, and we want to know, and it specifically tells us there are three possible values of x. We have to find them, and we have to find their sum. So we have to think about, we have to like divide this into casework, and like depending on what value of x can be, the median will be different, right? So you can see that if x is between 15 and 25, then the median will be equal to x. If x is greater than 25, then the median will just be 25. And then if x is less than 15, then the median will just be 15. And then we want to equate the mean to the median in each of these cases. So the mean of this is just going to be, so we can just divide each of the integers by 5. So then it's going to be 7 plus 3 plus 1 plus 5 plus x over 5. So then the mean, so this is the mean. So the mean is going to be equal to 16 plus x over 5. So then in this case, we have 16 plus x over 5 equals 15. In this case, 16 plus x over 5 equals x, and then in this case, 16 plus x over 5 is equal to 25. So we can solve the first case here. Oops. So we're going to have x over 5 is equal to -1, and then x is equal to -5. And then, so you have to check that this answer is consistent with your case first. Is -5 less than 15? It is. And is it an integer? Yeah, it is. So this is a possible value of x. And then we can solve our next case. We're going to have 4x over 5 is going to be equal to 16. So then x is going to be equal to 20. And then check your case. Is 20 between 15 and 25? Yeah, it is. And it's an integer. And then our next case, we're going to have x over 5 is equal to 9. So then x equals 45. 45 is greater than 25. It's an integer. And then we see that we have three possible values of x, and then we just need to sum all these together. And then the sum is going to be 60. That's the answer.
Yep.
Anything you want to do?
Like, no. I
Okay.
think this problem's not that hard. I mean, if you have like a cast, you can just like solve it with a cast, I guess.
So what?
Don't worry about it. Okay, never mind.
Okay.
Okay, next
Okay.
question, I guess.
Next question. Harry and Mary are on a straight road traveling towards each other. Harry is traveling at 20 miles an hour, 20 miles per hour, and Mary is traveling at 40 miles per hour. When Harry and Mary are 12 miles apart, Zeke passes Harry while traveling 50 miles, 50 miles per hour in the same direction as Harry. How many miles apart are Harry and Mary when Zeke passes Mary?
Okay. Uh, so Harry and Mary are 12 miles apart. Okay, so this is actually kind of hard for me to visualize at first. So I'm gonna draw it out since it was so hard for me to visualize. So
Yeah.
Harry,
It's generally a good idea to like draw stuff out as much as you can because it just gives you like a picture of
So
what's
Harry
happening.
is going at 20 miles per hour. Mary is going at 40 miles per hour. And then Zeke passes Harry while traveling 50 miles per hour in the same direction. So Zeke is at 50 miles per hour. So at this point, they're 12 miles apart. So there's 12 miles here. So how many miles apart are Harry and Mary when Zeke passes Mary? So for Zeke to pass Mary, they basically have to combined cover this 12-mile distance. So they are combined traveling at 50 and 40, so 90 miles per hour. So to travel the 12 miles per hour at 12 miles at 90 miles per hour is just 12 over 90 equals 7. My bad. It should be uh hang on. Right. It should be 2/15 of an hour. 2/15 of an hour. So now we look and see how much distance Harry and Mary together, because now we're looking at how many miles per hour Harry and Mary after 2/15 of an hour, which is like 8 minutes. But since we're talking about hours here, we're just gonna keep it in hours. So Harry and Mary together are traveling combined at 60 miles an hour. They're approaching each other at 60 miles per hour. So they will travel at 60 miles per hour. They will be traveled. They would have traveled 8 miles in 2/15 of an hour. So 12, they originally had 12, and then they covered 8 miles, so they would have 4 miles left. Yeah, and they will be 4 miles apart.
Yeah, and that's the correct answer. I don't really have anything to say. Okay, next question. The frustum of a right circular cone is formed by cutting a small cone off the top of a larger cone. If a particular frustum has an altitude of 24 centimeters, the area of its lower base is 225 pi square centimeters, and the area of its upper base is 25 pi square centimeters. What is the altitude of the small cone that was cut off? So we have a frustum and a small cone. Um, actually, I can just draw on the picture that it gives us. So, um, here, I'll make it here actually. So here's the frustum, and then the small cone is on top. And it tells us that the frustum has an altitude of 24 centimeters. And the area of its lower base is 225 pi squared centimeters, but the area of a circle is just pi r squared. So then the radius of that circle is just going to be 15 centimeters, right? So then I could say that this is 15 centimeters. And then likewise with the upper circle, if the area is 25 pi squared centimeters, then the radius of that circle is going to be 5 centimeters. So this is 5, that's 24, and that's 15. And what we want to find is the altitude of the small cone. So we can label that as x. And then you can see we can form two similar triangles here. So the first triangle is going to be this triangle with the radius of 5 and the altitude of x. And then the second triangle is going to be this larger triangle. It's going to have an altitude of 24 plus x, and it has the other leg of 15. And so like why it's similar is because like both share a right angle, and they also share this same angle because um, they're formed by by the same line and two parallel lines, right?
Yeah.
Okay, so then those two triangles are similar, so their ratios are the same. So I can say that um, x over 5 is going to be equal to 24 plus x over 15. So then 15x is going to be equal to uh, 120 plus 5x. So then 10x is going to be equal to 120, and x is just going to be equal to 12. So then our answer is 12 centimeters. And yeah, that's the right answer.
Yeah. So when you have like a so when you have like a triangle and you just cut the triangle with a line that's parallel to its base, then like that triangle, the smaller triangle and the big triangle are similar. It's
Yeah,
kind of just like
or
always.
yeah, or you could have also said that they just share this same smaller angle
Yeah. Okay.
on the top. Okay, next question. A circle is inscribed in a rhombus, the lengths of whose diagonals are 2 feet and 4 feet. What is the area in square feet of the region of the rhombus that is outside the circular region? Express your answer as a decimal to the nearest 10. So we have a rhombus. The diagonals are 2 feet and 4 feet. So we can use this picture here. So this diagonal is going to be 2 feet, this one, and then this larger one is going to be 4 feet. But I'm just going to label like the smaller ones. So the diagonals are going to be cut in half. So it's going to be 1 and it's going to be 2. What we want to find here is the radius of the circle, right? Because if we find the radius of the circle, then we can find the area of the circle, and we can also find the area of the rhombus because we already have the lengths of the diagonals of the rhombus. So all we need to find is the radius of the circle. So we have to try to find a way to find the area of the circle. And a clever way of doing that is looking at this triangle here, this triangle right here, and we're gonna put the radius, or sorry, the center of the circle out to this tangent side right here. And because the circle is tangent to this point, this is going to be at a right. This is going to be at a right angle, right? So what we see here in this triangle is that we have two like pairs of heights and bases, right? So we have two ways of expressing the area of the triangle, right? So one way is with this height of 1 and this base of 2 right here, right? So then that tells us that the area of the triangle is 1/2 times 1 times 2, which is just 1, right? And then the other way of expressing the area is with this radius r of the circle, and then this side this side of triangle. And how we can find that side is with the Pythagorean theorem, right? Because we have a right triangle and we have two legs, right? So then this side is going to be root 5. So then we can say that the area of the triangle is also equal to 1/2. Wait, oops. Uh, we can say that the area of the triangle, which is 1, is also equal to 1/2 times root 5 times the radius. So then we can solve for the radius here. The radius is going to be 2 over root 5. I can rationalize this into 2 root 5 over 5. Okay, and then so now we have radius. We can just find the radius, or sorry, the area of the circle, which is just going to be 4 times 5 over 25 times pi, which is equal to 4/5 of pi. And then the area of the rhombus is just going to be the product of its diagonals over 2. So the area of the rhombus is going to be 4 times 2 over 2, which is 4. And then the area out so the area of the region of the rhombus that's outside the circular region is going to be 4 minus 4/5 pi. And then it tells us to express our answer as a decimal to the nearest 10. We have a calculator, so we can just that in, and then we see that our answer is 1.5. Okay, anything you want to say there, Bill?
Um, I mean, I think you did. I think you're fine.
Yeah.
Okay.
It's 3:30 now,
Yep.
so we can just end it there.
Okay. Well, thanks for coming.
Yeah, and we'll see you guys